Hello there again. Let's finish up notes lesson 11.3, simplifying rational expressions. So this is part 2. This is the second video. And I told you we would do 2 more examples. So here's example 4. Let's say you have d squared minus 4 all over 2 minus d. Okay. Common mistake, kids try to cancel d's and they try to cancel the 2 and the 4, but you cannot. You cannot cancel yet because of the subtraction. Alright, you can only cancel if there is multiplication. So if it's factored. So let's factor first. Alright, the numerator is a difference. Difference means subtract. Of 2 perfect squares. That's d times d, and that's 2 times 2. So we've learned how to factor difference of perfect squares. It'll factor into 2 binomials. One will be plus, and one will be minus. So you take the square roots of each term. Square root of d squared is d. Square root of 4 is 2. And one's a sum, and one's a difference. Now, this binomial looks very similar to this one. Alright? These two are very similar. They're close. So we can do a little math trick here. So out of this one, we're going to factor out. So we're going to take this, and we're going to factor out a negative 1. Okay? So negative 1 times what is 2. Well, a negative times a negative is a positive. So negative 1 times negative 2. And then negative 1 times what is negative d? Well, that'd have to be a negative times a positive to get a negative. Okay? So I factored out a negative 1. When I factor out a negative 1, this turns from positive to negative. And this turns from negative to positive. Now I'm going to do one more little trick. I'm going to keep that negative 1 out front. And instead of writing negative 2 plus d, I'm going to put the plus d first, then the negative 2. So I'm going to put d minus 2. Alright, and that is going to go in the denominator. So I'm going to write negative 1 times the quantity d minus 2. Alright, now we have a match. D minus 2, d minus 2, they're being multiplied. So when you cancel, you're canceling out the entire quantity. The whole thing cancels. Now that leaves you with d plus 2 divided by negative 1. And that means, oh, whoops, I don't want to do that. Let's start over here. So I had d plus 2 over negative 1. That's d being divided by negative 1. And, plus means and, 2 being divided by negative 1. So when d gets divided by negative 1, that gives me a negative d. And when positive 2 gets divided by negative 1, that gives me a negative 2. Alright, you might need to watch that one again. Definitely to kind of think through what we did. So we factored a difference of perfect squares. This quantity and this quantity almost matched. They're in the wrong order. So to switch this order, I factored out a negative 1. A negative times a negative is a positive. A negative times a positive is a negative. Then I switch those two around, put the positive d first, and the negative 2 second, Then I took that and wrote it. Now these match, and I cancel the whole thing, not individually, not D with D and 2 with 2, or negative 2 with 2, the whole quantity, because they're being multiplied. And then here, not only the D is being divided by negative 1, but and the 2 gets divided by negative 1. And then there's one more thing, excluded values. So look in the denominator, even the stuff that's canceled, and D can't be 2, because what's 2 minus 2? 2 minus 2 would be 0, and 0 times negative 1 would give you 0 in the denominator. So D cannot be 2. All right, one more to go. This is our last example. This is number 5. Let's say you have s squared minus s minus 6 divided by s squared minus 7s minus 18. Okay, again, you're going to be tempted to cancel like s here. And you're going to go, well, there's multiplication, but the whole, look, subtraction, subtraction, subtract. No, you have to have everything multiplied or quantities being multiplied. So factor first, factor first, factor first. All right, is there a GCF? No, they don't all three have S. Is this a difference of perfect? No, this is a trinomial. And it's an easy trinomial because it has a leading coefficient of 1. So in an easy trinomial, I'll do it down here. Just use the X trick. So what multiplies to negative 6 and adds up to negative 1? Right? What multiplies to negative 6 and adds up to negative 1? Let's see. What multiplies to negative 6 and adds up to negative 1? I think that will be negative 3 and 2. All right, so there you go. Use those for your factors. You're going to have s minus 3 and s plus 2. All right, and now those are being multiplied. So I've got it factored. All right, the next one underneath. This is another easy trinomial because it has a leading coefficient of 1. So we'll use the X trick on this one too. What multiplies to negative 18 and adds up to negative 7 has to multiply to negative 18 and add up to negative 7. I believe that's going to be negative 9 and positive 2, right? Negative 9 and positive 2. So there you go. You're going to have s minus 9 times the quantity s plus 2. And that's factored. You have quantities. Oh, look, look, look. We have a match. We have a match. So you can cancel that entire quantity with that entire quantity. And you're left with s minus 3 divided by s minus 9. And that is your final reduced answer. You cannot cancel these s's because they're being subtracted, or there is subtraction involved. You cannot cancel 3/9 here. No, 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 because there's subtraction. You can only cancel when you have multiplication. All right, excluded values. Look at the denominator, like before you canceled. What would make this 0? Well, s can't be 9, right? What's 9 minus 9? 9 minus 9 is 0, so s can't be 9. And over here, s can't be negative 2, because what's negative 2 plus 2? Oh yeah, that gives you 0. So s can't be negative 2. And there's your excluded values. All right, I hope this is helpful. Feel free to re-watch, rewind, ask me questions. Good luck.